I come from Saudi Arabia, from Princess Nourah bint Abdulrahman University, College of Computer Science and Information Technology Department. And it's my honor to be here and present you our paper, a blockchain-based blood donation system, enhancing traceability in blood supply chain management. Based on this outline, we're going to start with introduction about blood donation, and then a problem statement. After that, proposed solution, and the related work, implementation plan, system design, next future work, and last conclusion. As everyone aware, blood is one of the most essential components for existence. 3 lives can be saved by single donation, but many countries still face shortages and insufficient access to save blood. And this shortage causes individuals to die every day. Within hospital walls, 1 in 7 individuals awaits blood transfusion, highlights the urgent demand for blood. Additionally, someone needs blood every 2 seconds, which emphasizes the need of blood donation in a saving life. For this reason, addressing issues with the blood supply chain management is crucial. In this paper, we propose utilization of a blockchain technology as a solution to address the challenges and limitations in blood supply chain management within Saudi Arabia. Our goal is to provide creative and practical solutions that can enhance the efficiency and effectiveness of a blood supply chain management. The Ministry of Health in Saudi Arabia recognizes the benefit of a blood donation, emphasizing its critical role as a lifeline for recipients. The definition provided by the ministry described the blood donation as a simple medical procedure that contributes to save lives, where healthy individuals voluntarily donate blood, and the donated blood carefully examined and preserved so that it can be used to treat another person in emergency cases that required blood transfusion or for individuals who required long-term treatment. Before delving into a proposed solution, it's crucial to understand the existing centralized systems of blood supply chain management in Saudi Arabia. This system typically involves 6 stages of blood collection, separation, testing, storage, distribution, and transfusion, as shown in this figure. This understanding provides foundations for evaluating the potential challenges that can address it through the implementation of a blockchain-based solution. The first stage is the blood collection. Once the donor is deemed eligible, a certain amount of a blood donation is drawn from donor and collected in a sterile closed bag. After collection, the donated blood is separated into its components, such as red blood cells, plasma, and platelets. This allows for targeted usage and storage of a specific blood component based on a medical requirement. Following that, a testing stage, where the donated blood units go through laboratory testing to ensure safety and suitability by checking for infectious diseases. The 4th stage is storage, where the donated blood are stored under appropriate condition and prepared for transport. Additionally, all relevant metadata, including blood-related information, is stored in a central database. In the 5th stage, known as distribution, the blood is made available at central bank and then delivered to hospital. While hospital may have some units available in their clinics, there is a constant need for additional blood units, especially in emergency situations. It's important to note that the main health provider in Saudi Arabia is the government, specifically the Ministry of Health. However, there are also independent organizations that deliver government-supported health services. Each of these hospitals has its own hospital blood bank, which is responsible for all transfusion-related functions. These include attracting donor, processing blood components, and ensuring their proper storage. Although these hospital blood bank are required to follow the guidelines set by the Ministry of Health, they operate independently with the hospital structure. The final stage is involve transfusion of a stored blood component in a patient in need. Now that we have outlined the stages of a blood supply chain, let's move on to identify the current problems associated with each stage. In the first stage, blood collection, a significant problem is the gap between donated blood and actual demand for blood. Despite ongoing efforts, there is a global shortage of a blood supply in many countries, as highlighted in 2017 study that identified shortages in 119 out of 195 countries. This shortage poses challenges in meeting healthcare systems' need for a blood transfusion and a medical procedure requiring blood. In Saudi Arabia specifically, a study has predicted significant increase in blood demand, indicating a growing need for blood transfusion and other medical procedures that require blood. Regular blood donation is crucial to address this growing gap between donated blood and the supply, and eventually save a life. In the second and third stage, separation and testing, they involve critical medical procedures that are not within the scope of this research. Instead, our focus will be tracking the journey of a blood and its components throughout the supply chain. The objective is to gain understanding of the various stages involved. Moving to the fourth stage, storage, it's essential to address the challenges posed by centralized servers in a blood supply chain. These centralized systems present single point of failures, increasing the risk of data loss, system downtime, and potentially life-threatening consequences. In the fifth stage of a blood supply chain distribution, several problems hinder its efficiency and effectiveness. These problems include lack of detailed blood tracking information, lack of real-time information, lack of direct communication and transaction, and lack of blood conservation. Blood tracking data is insufficient and incomplete due to the fact that the current centralized blood management system lacks comprehensive tracking mechanism. This is made worse by shortcomings in the current systems, which is make it more difficult to precisely track the movement and the status of a blood unit during the distribution process. Lack of detailed blood tracking information contributes to the second issue, which is lack of real-time information. The absence of real-time information about blood availability and demand leads to significant challenge during transfusion and insufficient utilization of blood resources. The fragmented of a blood bank system in Saudi Arabia, which each entity managing its own blood bank hospital, as I mentioned before, creates challenge in establishing direct communication and collaboration between medical facilities. This lack of a streamlined communication channels hampers efficiency and timely blood supply chain management. Lack of direct communication and transaction can lead to wastage, where excess of blood stock are not effectively allocated and distributed. As example from India and United States highlights the significant blood wastage. Thousands of units were wasted in India despite the critical shortage. Also, component waste rates in US range from 1 to 5%, putting patients who required urgent transfusion at risk. The primary cause of this imbalance is the lack of effective communication and collaboration between areas with the excess of blood supply and those experiencing shortages. In the second stage of a blood supply chain, which is transfusion, the fear of receiving contaminated blood haunts patients and hospitals. Incidents of patients contracting infections such as HIV, AIDS, and syphilis due to contaminated blood have occurred, causing harm and mistrust in the healthcare system. In fact, over the past 2 decades, there have been reported cases of 600 US patients infected with the HIV, AIDS, and syphilis, as well as over 10,000 HIV cases in India between 2010 and 2017, or resulting from transfusion of contaminated blood at blood donation facilities. Building trust, preventing errors, and maximizing data visibility are indeed essential in a blood supply chain management. Now that we have discussed the existing centralized system in a blood supply chain management and identify the challenges in each stage, let's move on to exploring the proposed blockchain-based blood donation systems and how it can address this problem. Creating a blood supply chain management based on blockchain technology can be a transformative solution to address issues present in the current system. This stage enables comprehensive tracking and validation of blood information throughout each stage of the supply chain, mitigating the risk associated with the traditional supply chain. Moreover, the system facilitates direct communications between hospitals, eliminate intermediaries, and enable seamless collaborations between them, and real-time information sharing and ensure that blood units are allocated efficiently to meet patients' needs. Furthermore, centralized database problems can be solved by using decentralized database such as a blockchain. Delving into each stage, the first stage, the key to solve donor shortages lie in a motivation and appreciation. It's essential to actively encourage and promote blood donation. Our suggested solution would notify donors whenever their blood is used. provide them with the information on where and how their donation made a difference, which highlights its impact and inspire further donation. In addition, integrated point system exchange for medical discounts as a thanks for their contributions, as a study shows rewards encourage repeat donation. In the second and third stage of a blood supply chain, QR codes play a crucial role in effective blood tracking, embedded into a blood bag themselves. These codes serve as a unique identifier and contain detailed information such as status, expiration date, and testing results. By simply scanning QR codes, healthcare professionals can access the stored information, enable real-time visibility and traceability of a blood units. In the fourth stage of a blood supply chain, the presence of centralized database can introduce to significant risk. To address these concerns, our proposed solution involves decentralizing the blood supply chain. By adopting decentralized approach, we eliminate single point of failures and minimize the potential for data loss or system downtime. This decentralizing system ensures that critical blood data remains accessible. By decentralizing the data across multiple nodes in the network, we establish more resilient and secure systems, reducing the vulnerability associated with the centralized database. Decentralization enhances the reliability and integrity of a blood supply chain, safeguarding critical information and ensuring that continuity of healthcare service for everyone involved. In the fifth stage, the current system's lack of detailed blood tracking information and real-time information on a blood component, hindering efficient management and raising concerns about traceability. To address this, we propose a blockchain-based solution that tracks blood components from collection to consumption, ensuring traceability and accountability. The use of a blockchain ensures secured information visibility with an encrypted and immutable record, as the detailed blood information is reflected in real time, ensuring efficient monitoring of the flow of blood and associated information. Furthermore, for the lack of a direct communication and transaction, the blockchain systems enable hospitals to bypass intermediaries, facilitating immediate blood exchange in emergency situations. This streamlined process eliminates delays and ensures that patients receive the required blood units without any delay. The direct communication between hospitals facilitated by blockchain systems allows for efficient collaborations and faster response time during critical situations. To address the shortage of a daily blood donation at each hospital, the proposed system sent alerts to registered donors to notify them to make a donation. This targeted approach helps close the supply gap more quickly, mobilizing available donors in a timely manner. Additionally, the blockchain system facilitates communication between regions with the surplus blood stock and those experiencing scarcity, allowing for direct blood exchange that helps prevent unnecessary blood waste. This redistribution of blood units based on a demand helps address regional imbalance and optimize the allocation of a blood supply. In the sixth stage of a blood supply chain management, our solution leverages blockchain technology to mitigate contamination risk and enhance transparency. By utilizing blockchain, we create decentralized and immutable ledger that record reliable information at each stage of supply chain. This ensures that the source of a blood can be verified, reducing the potential for contamination or counterfeit blood products. The transparency provided by blockchain empowers hospitals and patients with the detailed information about the blood they receive. This increases the transparency, promotes trust and accountability within supply chain, ultimately enhancing patient safety and confidence in a blood donation process. By utilizing blockchain technology, we can revolutionize the blood supply chain, addressing critical issues such as a contamination risk and lack of transparency. The decentralized and tamper-proof nature of a blockchain enhances the integrity of the system, providing reliable and transparent records for each blood unit journey. This transformation has the potential to significantly improve safety, efficiency, and effectiveness of a blood supply chain management. In this section, we offered a comprehensive overview of a previous research conducting on utilization of a blockchain technology and a blood supply chain management. It's a present examination of studies focusing on a supply of blood and explores instances where a blockchain has been integrated into supply chain management. This section concludes with a discussion of the special features of this work and setting a groundwork for the importance and contributions of this research in the field of blockchain-based blood management. In the first paper, implementation of a blockchain-based blood donation framework present the main idea is to propose blockchain-based system to enhance the blood donation process in India. The system aims to improve blood donation experience in the country by tracking donation history and sending notifications to donors, reducing waste and ensuring timely medical care. In the second paper, implementation of a blood cold chain system using blockchain technology, the author proposed a blockchain-powered solution to enhance the blood cold chain management for direct blood transactions between medical facilities. The primary objectives of the systems are to improve response time during emergencies and enable real-time data sharing among relevant stakeholders. In the third paper, implementation of a trust-based blood donation and transfusion systems using blockchain technology is to propose a blockchain-based system that addresses key issues related to blood donations and transfusion in India. The system aims to enhance safety and transparency by leveraging blockchain technology. It's specifically focusing on mitigating risk associated with the infections, transmissions, improving traceability, and enhancing quality control measurements. The fourth paper, blood and its product supply chain management based on a blockchain approach. The main focus of this solution is to utilize decentralized distributed ledger powered by blockchain technology. It's effectively manage the flow of blood and its derived products throughout the supply chain. The proposed systems aim to manage blood and its derived products. The main idea of the last paper, blockchain transparency in healthcare, blood donation, blood supply chain, it's to propose a blockchain-based solution for managing the blood donation supply chain. The paper suggests using blockchain technology to track the journey of blood units throughout the supply chain. By utilizing smart contract and decentralized nature of a blockchain, the system aims to enhance integrity and trust within the blood donation process. While most of these studies focusing on a few particular problems, our approach differs in that it's provide features that cover every category. Donors integration is a given priority through incentives and notifications. Patients who have blood tracking capabilities, we guarantee openness and enable tracking for whole blood components. We help donors and hospitals communicate directly in order to meet urgent requirements. For effective tracking, we make use of technology such as QR codes, and as a reward, donation point is used to ensure repeat donation. At the end of the sections, in the realm of healthcare, the importance of efficient and reliable blood supply chain management cannot be overstated, given its critical role as a life medical procedure. The life-saving capability of a blood donation is made manifest with every heartbeat that continue unabated, underscoring the urgency and necessity of optimizing the blood supply process. This paper delving into challenges and shortcomings inherent in the current blood supply chain and propose a solution, the adoption of a blockchain technology to enhance the blood supply chain management. Now moving to the implementation. The system architecture of the proposed blood supply chain is shown in this figure. The system is a comprehensive web application that includes back-end interface and integration, all built on organized architecture. The system architecture, as shown in the figure, provides visual representation of the components and their interaction. To access the website, user utilize the browser and log in using MetaMask, which is perform verification. Once authenticated, user can interact with the front end of the application, which is developed using HTML, CSS, and JavaScript framework like React. The user interface design provide visual, appealing, and user-friendly interface for user to interact with. This is where they interact with the system to donate, track blood, and more. On the back end, the system employs Solidity programming language specifically designed for writing smart contracts on the Ethereum platform. The interaction between the front end and the blockchain is facilitated using ethers.js library, enabling seamless communications between the user interface and underlying blockchain technology. For the development of a smart contract, the system utilizes various tools and environments. Remix serves as an editor and simulator for writing Solidity smart contract. Ganache, local blockchain network, is used for testing development purpose. Truffle, a popular development framework for Ethereum, provide additional tools and utilities to streamline the development process. Overall, the proposed systems architecture ensure well-organized and effective structures, allowing for the smooth functioning and integrations of its back-end user and blockchain. In this section, we will discuss the design of the system, specifically the data flow. As shown in the figure in number 1, for increasing dependability and security, the administrator can add hospitals to the system, which in turn allow hospital to add patients. Additionally, the donor have the option to register with the systems, which may involve giving personal information, among other things, as in number 2. In addition, there are sections for tracking blood. You can see it in number 6. That lets a patient and donors follow the blood and let hospital to update the blood status and enable donors to view his donation history, as in number 7. Furthermore, hospital have the option to notify donors through the notification sections in number 8. Additionally, hospital can add extra blood notification stack to support hospital in need and facilitate communications between facilities, as in number 9. And enable hospitals to send requests for blood units from another hospital, so as in number 10. And its hospital rejects or accepts requests, as in number 11. In future work, our primary objective in the coming months is to focusing on implementing the proposed blockchain-based blood donation system. The main goal is to develop comprehensive web application that incorporates all the desired features and functionalities. By focusing on implementing a blockchain-based blood donation system, we aim to provide a practical solution that enhance the overall efficiency and effectiveness of a blood donation management, benefiting donors, healthcare providers, and patients alike. Blood donation charters present formidable challenge, with the more than 100 countries reporting significant shortfalls, impacting the ability to meet healthcare needs of a population. These charters underscore the critical need for innovative solutions to improve a blood management system. Emerging study advocates for utilization of a blockchain technology as a means to foster the development of a dynamic and effective blood management solution across various domains. Recognizing this potential, our research proposed blockchain-based solution aimed at revolutionizing blood supply chain management within Saudi Arabia and eventually all over the world. This paper provides comprehensive analysis of the current states of blood supply chain management in Saudi Arabia, identify key challenges, and present a detailed proposal for a blockchain-based solution. Through theoretical exploration and practical consideration, it's aimed to demonstrate how blockchain technology can serve as a cornerstone for a more efficient, transparent, and transparency and responsive blood supply chain. The ultimate goal is to pave the way for a future where blood management systems are capable of meeting healthcare needs with unprecedented efficiency and reliability, thereby saving more lives and enhancing the quality of healthcare delivery. In conclusion, the interactions between blockchain technology and blood supply chain management offers a promising avenue for addressing long-standing challenges within healthcare sector. By embracing this innovative approach, Saudi Arabia can lead the way in transforming blood supply chain into models of efficiency and reliability, setting benchmark for others to follow in the pursuit of excellence in healthcare and patient care. At the end, thank you all for listening.